everyone. Thank you for coming to my session. So this talk is about obscure features of Unity. So over the years, Unity has built up an impressive list of features that are powerful and useful. But some of these features are buried deep in a long release note or just not well documented. So developers may not be aware that such features exist. So a while ago, I saw this tweet, and turns out the end of a bamboo stick, chopstick is meant to place your chopstick. So my mind was blown. And likewise, when I started Unity, the way I place camera is I use the translation and rotation tool to do that, until someone showed me a better way with the align with view, right? So these are just some of the examples. Like sometimes you discover some of these features through word of mouth or through someone else, right? Or you discover it by accident. So my name is Fei. I'm a lead field engineer for Southeast Asia and New Zealand, Australia and New Zealand. So while this talk is not about showing you new and shiny features, but hopefully this talk is able to give you a feeling of joy and amazement of discovering something old that can still be very useful. So the first one that I want to introduce or want to show you is the audio spatializer. So audio spatializer, or rather spatialized audio, will try to mimic how you perceive sound in 3D space. So there are some spatialized audio where you have the left and right ear. Maybe the volume on the left side is louder than the right to make it seem like that object or that sound is coming from the left or from the right. But with spatialized audio, it's 3D, meaning you can perceive, you will know whether this audio source is in front of you or at the back or maybe on the top or bottom. It's in 3D space. And Unity has some audio spatializer built in, but if you want to write your own audio spatializer, you can. So if you use one of these built-in ones, all you have to do is then go to your audio source, check that checkbox that says spatialize, and turn that slider from 2D to 3D. If you use the Oculus spatializer, Oculus recommend using their helper script for this. And you can find out more about these two spatializers from these two links here. So with spatialized audio, you can add more immersiveness to your game or your application, and it's especially useful for VR application. Next is Culling Group. So I saw this on the manual by accident. I was looking for something else and saw this, and then I realized that this is something very useful. So this allows you to query an object's visibility and distance in a very efficient manner. So very, very similar to how the built-in LOD system works. You would specify objects in distance band. So let me show you a demo. So here I have this Culling Group manager here set up. All it does is it will spawn 2,000 spheres, and then in a radius of 50 units. And then I have two distance bands specified. So first distance band is within 10 meters. Second distance band is within 50 meters. So let's take a look. So if I start going to play mode now. So you see this. So there are 2,000 spheres here, and they are all moving randomly. And I have this cube here that represents my player. Right, so this cube represents my player. And you can see, like, within a certain radius or distance away from my player, the spheres will be colored red. And if we zoom in closer, you can see, like, as they enter and exit my radius, they will update their colors. So if I move around my player, you can see it's updating very fast and efficiently. So imagine doing this with your usual way of doing, like querying all 2,000 objects and checking for distance, right? This is going to be very expensive on your CPU performance. So this allows you to have a very quick way of querying and do things efficiently. So for example, you may have like an area of effect kind of attack. So this is a very good, easy way to create, so these units will be affected by the attack, for example. And in the earlier example, for the spatialized audio, so spatialized audio does add some additional CPU costs. So if you have a lot of audio source and you've turned everything to spatialized audio, so 3D spatialized audio, it can be expensive. But you can use this Culling Group to maybe limit it to audio source that are within a certain radius. Then you turn it to 3D. If it is outside of the distance band, then you keep it to 2D, so it's cheaper, right? Likewise for AI. So like agents that are within the radius, they will exhibit more complex AI behavior, while agents that are outside of the distance band use simpler AI. And you don't, maybe you don't even have to animate them. You can also do things like this, because you can also query not just the distance, but visibility. So for example, in the same setup here, I have my player here. But this time, I made the camera a child of my player. So it's always looking from downwards. So this time, I can check, is the sphere within the radius? It is. If it is, then I will render them. Otherwise, they'll be disabled and not rendered, right? So all 2,000 spheres are still there. It's just being disabled, and only those within my radius is being enabled and rendered. So this is a way for you to create like a custom culling system. So let me just show you real quickly the code here. So to implement this, it's not something like you can just check a checkbox. Unfortunately, you have to do it through script. So let me show you the important bits here. So this code here, all it does is just spawn all the spheres, right? It's not that important, but this is the important bit. You have to create an instance of the Culling Group, and then you listen to the state change event, and then you specify the target camera. You set your distance reference point, which is, in my case, the player, right? So this is my player. And then you set your bounding distances. And this is the distance band. So in my case, I have 2 distance bands. You can have more if you want. And finally, you will set all the bounding spheres for all the objects. So I have 2,000 spheres. All 2,000 spheres, I will add a bounding sphere and add that array of bounding spheres to the Culling Group. And that's it. So then you need to handle the events, the state changes in your function here. So what I'm doing here is just checking if something has become visible. If it does, then I'll show it. Otherwise, I'll disable it. Or you can check for distances. So for example, here, if the distance is within or is within the first distance band, I'll color it red. Otherwise, I'll color it blue. That's it. So don't let the code distract you. All you need to know is this is the overview. So you need to create a new instance of Culling Group, set bounding spheres to every object that you want to check against, assign that bounding sphere array to the Culling Group instance, and listen to the state change event. And then you can handle it whatever you like in that state change event. You can find out more from this link here. It's on the manual. So next, I want to show you replacement shader. So if you are an effects or image effects artist or programmer, you may be familiar with this, but otherwise you may not know that this feature exists. So for every material, it is a container for shader. So in your scene, you may have multiple different containers, and that also means there are multiple different shaders that are rendering or used for rendering your object, right? So what replacement shader does is it will replace every single different shaders in your scene with this specific shader. So imagine in your scene, if you have shader A, B, C, and if you specify replacement shader 1, this will be used to render all objects instead of shader A, B, C. Okay, so let me show you an example and how this can be useful, not just for image effects, but for production or your development or workflow. So here I have an image on the left. That's my camera view. And on the right, I've applied a replacement shader to visualize the map. And you can actually use this to check if your texture density, is it too high or too low? So then you can optimize. So maybe you know that, okay, this texture is too high, right? You downres it, so it uses less memory. If it's too low, then the texture may be too blurry. Then you may want to increase the texture density for that. So Unity's scene view comes with the map visualizer. Let me show you. This one, okay. So if you go to the scene view, there's a map visualizer. This one here, right? And you see this thing. So like, if you see it colored as red, that means the texture density is too high. If it is colored as blue, then it is too low. If it is the right color, then you are at the optimum texture density. So like if I zoom way out, that means like all this texture is now too high res, right? If I zoom in, then this is just nice. So this is a convenient way of visualizing it, but it is not very useful because you're looking through the scene's camera, right? While your game may be on a different camera angle. So like maybe your game is a top-down game like that. It's a fixed camera angle from top-down. Then you're not exactly visualizing your texture density correctly, right? You may have a different FOV, for example. So for cases like this, then you can use a replacement shader. So I have written a tool, for example, to assign my my game camera, this guy here, my game camera, assign it here, and I can apply a shader, a replacement shader, to visualize the map. So let me show you. So visualize, and now I can see, oh, this guy, the texture density is too low. So I may have to bump it up, for example. And this texture on my shark character here is also too low. I may want to consider bumping that up. And then you see these poles here, they are red color. That means the texture density is too high. I'm wasting a lot of memory. So you can consider downresing that. So this is one way where replacement shader can be useful for your workflow or production. You don't necessarily have to use it just for image effects. So again, unfortunately, this is not something that you can just check a checkbox. You have to enable this via script, but it's fairly simple. All you have to do is call the function set replacement shader on the camera that you want to add or replace shader with. So in this case, this camera refers to my game camera, and then I'm setting a replacement shader in my first parameter, the effect shader, and then I give it a tag. This tag is render type. So my replacement shader looks something like this. So it has two sub-shaders, and for each sub-shader, there is a tag specified. The first one specify render type opaque. Second one, render type something else. So in your scene, with all the different shaders, first it will look for shaders with the same tag, opaque. If there is such a shader, then that will be rendered with this replacement shader sub-shader. And if there are shaders with the tag something else, that will be rendered with this replacement shader's sub-shader. If there is a tag that doesn't fit in any of the tags in my replacement shader, then that object will not get rendered. Okay. Next one, shader variant collection. So not everyone, you may not be aware that when you are working with a standard shader, you're not actually working with just one shader. A standard shader will be compiled to multiple variants of that standard shader. So there will be a variant to handle point light, for example. There may be a variant to handle light maps, and there may be a variant to handle shadows. There are multiple variants that will result from that one standard shader. So from your point of view, you are just working with the standard shader, but on the back, in the background, Unity actually compiles to multiple different variants. And standard shader actually will result in over 10,000 variants. And that is a lot. So what usually happens is when you build your game, Unity will try to find out all the different variants that are needed for your game. And then when you run the game at runtime, different variants, when it's needed, it will be compiled. And this also means that compile time may affect your performance. You will see a frame rate drop. You might see a frame rate drop, depending on how complex that variant is. So to prevent this kind of performance drop whenever you have a variance that needs to be compiled, you can create a shader variant collection. So think of it as picking up the variants that you know you need, put it into a collection. So when your game starts, these lists of variants will be pre-compiled, will be pre-warmed, pre-compiled. So then when you run your game, there isn't a need to compile it. So you save on that, you prevent that performance or that hiccup, the frame rate drop. So next one, texture array. So if you're a programmer, think of it as your integer array or your float array or your string array. A texture array is a collection of textures. So if you're working with one texture, there's one object. If you're working with a texture array, this is also one object. But a texture array can contain multiple textures. So this is one example. So this texture array is made up of 4 textures. And I can access the different textures via the index. So let's say I want to render or I want to apply this texture on my model, and I want specifically the texture from index 1, then I'll pass in 1. If I want the texture from index 3, I'll pass in index 3. And now I'll get that texture from my texture array. So the nice thing about texture array is all these different textures, they are not treated as 4 objects here. Instead, they are treated as 1 object. That means, let's say I have 4 objects, and they are using a material that reads from this texture array. I can apply index 0 to my object 1, index 1 to my object 2, index 3 to my object 3, and index 3 to my object 4. I think I messed up the index just now, but yeah. And then these 4 objects is not 4 draw calls, it's just 1 draw call, because they are using the same texture array. It's treated as one single object. So in this screenshot here, you've probably seen it during the keynote. This is a project that is worked on by Sparks Vietnam. They wanted to try out Unity for real-time animation. So I did a proof of concept for them. They have this simple, not very simple, but they have this robot here and this scene here. And this robot is not just one single albedo map applied to the robot. It's actually 126 albedo maps applied to that robot. And we're talking per channel. So 126 albedo maps, 126 normal maps, 126 AO maps, 126 specular maps. And these are all 2K maps. So the reason for this is because for the VFX industry, it's common to use tools like Mari to use multi-texturing. So reason for that is because they want ultra high resolution. So because when they created the asset, they have no idea how the director wants to shoot the asset, right? Maybe the director wants to shoot it from a very close-up angle, or maybe from very far. They have no idea. So they have to create something that is ultra high resolution, that looks great from every angle, from every distance. And for that proof of concept, I use texture array. And for UDIM file format, which is a multi-texturing format, which is what they use for the project with Mari, it's multi-tile UV. So this means that your UV values is not restricted to 0 to 1, but extend beyond that. So you have 0 to 10, for example. So in this image here, you see on the U-axis, there are 10 tiles. And on the V-axis, there are 2 rows, right? And for the UDIM file format, it's standardized to be on the U-axis, you can have maximum of 10 tiles, but on the V-axis, you can have unlimited number of tiles. So every single one of these tiles is one texture, one 2K texture. So using this formula, you can calculate. So because we know on the U-axis, maximum you can have up to 9, and on the V-axis is unlimited. So using this formula, you do a floor of the X value of the UV, and then plus with the floor of the y value of uv multiplied by 10, you get the index. So like if you go from lower left-hand corner, that's index 0. As you progress from left to right, you get 0, 1, 2, 3, 4, 5 until 9. And then the second row will be 10, 11, 12, 13, and so on. So then going back to this example here, so for this robot, there will be one texture array with all 126 albedo maps. And to find out which index to use, I use this formula and then apply that albedo map, that 2K albedo map onto the robot. So this is one use case. It's not restricted to this use case. You can also use this, for example, like customization. So you have this character with different skins. And if you apply a different skin every time, that's a different material. But if you use a texture array, then you're using the same material. So you save on your draw call, for example. Another one is multi-inspector views. So surprisingly, well, especially for new users, what you don't realize is you can actually have multiple inspector views. And this can be very handy. So let me show you. So let's say I have an inspector view here, right? And I want to assign something to my slot. And I can actually right-click here, add tab, and I can add another inspector view. So I can pull this off, for example, and then I can maybe lock this one. Is it locked? So now, if I select something else, this is updated, but this stays at the original selection, and then I can then drag some components to my component here, right? So this can be very handy, especially when you have your custom components, right? And you sometimes may have multiple instances of that component assigned to that same game object. And you want to assign that specific component, maybe the second one, to a slot. So if you just drag that object directly to a slot, Unity will just take the first instance that it finds. And that may not be the one you want, right? You want maybe the second one. So this is one way to do it. And you realize just now, it's not just the inspector view. You can have multiple scene views, game views, hierarchy view, project, profile, and animation view. Cool. And so this is not in my slide, but as I was talking to developers or people, I realized not a lot of people know about this as well. So I'm adding it now. So you can also do this. So if you create an empty game object, right, in your scene, and that's cool, but as soon as you click away, you don't see it anymore, right? And you can't select it from the scene. You can't select it from the scene here. So what some developers do is they write a custom gizmo, attach it as a component, so then it shows something here that you can click. But actually what you can do is, with that selected, you can go to here, click on this guy, and click on some of these icons here. And now you have like a, oops, because and now you have, whoops, oh, I selected the wrong thing because it's locked. Newbie mistake, sorry. There you go. So now you have something to click on. Yeah, and added that thing to this thing. Cool. Okay. Next one, play mode Tint. So this is especially handy for new users because a common mistake is when you go into play mode, you made some changes and then you exit play mode and those changes are not saved. So new users tend to forget that they are in play mode and you made some changes, you thought you're done for the day, you finish your work, and then you realize you're in play mode. So all your work is gone. Next day you get scolding from your boss. So with play mode Tint, it gives you like a visual cue to let you know or to remind you that you are in play mode. So all you have to do is go to Edit, Preferences, and then under Color, there's this play mode Tint that you can select. So maybe set it to something like red. And then when you go into play mode, you scream like, you are in play mode, be careful, right? So I'll set this back because I'm a pro. No, just joking. Sometimes it still gets me. Okay. Next one. If you're working to build Android games, so the default behavior is Unity will render your scene to an off-screen buffer and Blit to the back buffer. So that means that you will be rendered to an off-screen buffer and then copied to the back buffer. And this copy process takes about 0.5 to 2 milliseconds. And that can be a lot, especially you are already performance bound, right? So you can actually disable this, set it to never to disable this. If you know that you don't require MSAA, and if you don't need linear color space, and you don't need to work in non-native resolution, you can safely disable this. Otherwise, you can select auto and then let Unity decide for you. Next one, grid snapping. So a while ago, I was watching this YouTube video. This presenter was comparing Unity with brand X, right? And I realized that this presenter didn't know that Unity has grid snapping feature. So actually, yes, Unity does support grid snapping. And all you have to do is hold down Control. While you move the object, it will be snapped to your grid resolution that you specify. I'll show you a demo. Next one is Vertex Snapping. So if you want more precision, for example, like you want this cable to be placed precisely at that point on that table lamp there, right? You can have that vertex on that cable match up exactly to the vertex on that table lamp. So again, all you have to do is just hold down the V key, hover your mouse to whichever vertex you want it to snap to, and then click and drag to the other vertex that you want to snap to. I'll show you a demo later. Collision snapping. So I don't know if you've done this before. Like you want to place something on a surface, like for example, this guy on this table here, right? And you usually do this dance, like you move it down, 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 down. Oh, penetrate, you move it up, and oh, it's too much, and then you move it down again. Like you keep on adjusting, but you can't really get exactly, let it sit on top of a surface, right? And that's very frustrating. But if you know that your surface has set up with a collider, you can use collision snapping to snap it on top, exactly on top of that collision box. So all you have to do is Control Shift and move that object, and it will snap to a collider surface. Next, you can run physics in editor. You don't have to go into play mode to see physics simulation running. You can run it in the editor. So here's an example of how this can be useful. So like if you have a scene, for example, the Book of the Dead scene, right, where there's a lot of branches or leaves or small rocks or stones, it will be very time-consuming to hand place every single one of these small objects. So maybe instead of that, just let physics do its things. So you just let them fall naturally, and then you have a very naturally looking or placed rocks or leaves or branches. So you can read more about this from this link here. There's an article, and the script is attached in the article. So let me show you a demo of all these different grid snapping and placement tools. So I have a very simple scene here. So I have this cube here. So for grid snapping, all you have to do is hold down Control, and then you move it, and you snap to the grid resolution that you specify. So to specify your grid resolution, you can go to Edit, Snap Settings, and you get this window here. So you can specify like on the x-axis how many units to move, and on the y and z-axis how many units to move. So here I've set my x-axis to 2 units. So every time I move on the x-axis, it's snapped by 2 units. And if you, let's say you play something randomly, like, right, and you get your position values like this. 2.5, 1.905, minus 1.883. So what if you want to snap to the nearest point on the grid? You can click on this button here that says Snap All Axis, and you snap to the nearest one. And now my position is 2, 2, minus 2. So this is grid snapping. Let me show you vertex snapping. So let's say I want this cube to place exactly at this corner, right? At this corner of the plane here. Let me show you in wireframe mode, right? So I can press the V key and then move my mouse to whichever vertex I want. So maybe I want this corner here, and I click and drag and snap to whichever vertex. So I want it to be this vertex. So then it is aligned exactly to that vertex, like that. Let me move this back. Next is collision snapping. So for example, I have a chair here, right? If I just do this thing, you know, like try to place it on the floor here, like too much, then move it up, right? It's a pain. So instead, what you can do, so this plane, there is already a collider. There's a mesh collider, right? So I can do this, select my thing, my chair, hold down Control and Shift, and then drag, and it will snap to the surface. So nicely placed on the floor there. Next one. So you can see these two cubes here hovering on top. I can run physics simulation and let them just fall down, and then they'll look very natural in my scene. Run this. You can see physics works in the editor. I don't have to go into play mode. Right. So to get this script, again, you can refer to that link here. Oops. So this link here. So as I started with a tweet, I will end with another tweet. So I saw this the other day, and it blew my mind again. So it turns out you can save selection sets in Unity. Let me show you. So like this simple scene again. So let's say I want this cube and this cube, right? I can go into Edit, Selection, and I'll save to my selection set 1. And I can select these two smaller cubes, this one, and I'll save to, sorry, I couldn't see it. Okay, selection 2, right? So now if I recall, I can recall my selection 1, load selection 1, and these two are selected. I can load selection 2, and these two are selected. So of course you can go with the shortcut. You can go with the shortcut keys here, Control Shift and Control Alternate Control or something. Damn it, it's loading. Yep. Can use the shortcut keys here. For loading, it's Control Shift plus the number. For saving, it's Control Alternate key plus the number. Cool. And that's all for my list of obscure features. I hope that was useful. And I'm sure some of you may have some obscure features that you know that other people don't know. So feel free to share with your friends or developers. Share the love, share the knowledge. And if you have questions, you can always reach me at this email. Otherwise, I hope you enjoy Unite Singapore 2018, and thank you.